All right, we'll give it another minute and then start. All right, let's get started. How's everyone doing? Good? All right, a few notes before we start. So lectures this week, I'm going to start by quickly covering the rest of the functional dependency and normalization chapter. We had a few slides remaining, so I'll go through that. But then for the remainder of this session and next session, we're going to focus on SQL. Now, there was an email that went out asking you to set up your UQ zones. If you haven't done so, please do so in the next week or so. I'm going to be running a lot of SQL queries during session, and I invite you to kind of run them with me in your own zones as we go through it. I'll give you a quick demo of how that would look during today's session. Anyone had any difficulties with setting up their zone? Has anyone tried setting up their zone? No issues? Pretty smoothly? Okay. I think it takes 15 minutes for it to start running. To actually get it there. Right. Okay, additional exercises. Guys, quiet down, please. So I am posting a bunch of additional exercises, right, without actually following up on them in the lecture. But I'm hoping that you guys are on top of this and you're going through the additional exercises and the exam mocks that I've provided just to make sure that you're preparing well for the midterm, which is coming up soon. Question? SQL is included in the midterm. In the mocks that I have, I think in 2 of them, there's a question which talks about reverse engineering a set of relations to an ER diagram. I haven't talked about that in this class and we're not going to cover it. So if you see that question, just ignore it. We haven't talked about reverse engineering. Okay, projects. Proposals are due this week. And we've got this form that you can report your weekly progress on. We'll use the tutors and I can kind of see where you guys are at. How's everyone with their projects? I see some happy faces, some not so happy faces, some confused faces. Make sure that you get some time with the tutors if you're still finding it hard to go through things during the tutorials, just to make sure that the project is coming along smoothly. I did post a sample of what that proposal should look like. I hate doing that because I said it kind of kills creativity and you're all going to just copy that template that I gave you. Please don't do that. But essentially, I just wanted to give you a sense of how much you need to write and to what extent you need to provide information about it. So take that, but don't copy that style, please. Be creative. Project Template Guide 4 is what we're going to focus on this week for you also to read yourself. Guys, you're talking, please don't be as I'm talking. Other people get distracted, I get distracted, and things don't go well. Ripple Round 1 is out. I'm hoping to post the results by the end of today. Nick was just working on it as I came in. And midterm, it's coming up, sample questions, make sure you're going through that. Any other questions before we start? Yes?
For Ripple, I know your resources have to be kind of approved so that you can get the rate. How long should we
So I went through all of them yesterday. So the question was, how long does it usually take for them to get approved?
Yeah.
It depends on how much help I get from you guys. I wasn't getting a lot of help from you guys, so I was going through the moderation a lot myself, so it took longer than anticipated. But I think all of them are now approved. About those questions, so if you're creating a question that's taken you 3 minutes to write, it's probably not a good question. Right? If you're spending 30 seconds copying things from somewhere, or you have a question which is just checking some memorization-based fact, please give it some more thought for your next resource. Right? Essentially, this is a creativity exercise, getting you to think about the sort of things that you think other people will find helpful. Make sure you kind of take that into consideration. There were some questions that I could essentially tell that it took the author 30 seconds, copy paste some stuff from some places over. Just not a great way to be creative. All right, let's finish what we did where we left off, and then we'll move on to SQL. So we were talking about BCNF, right? Board card normal form, and we talked about BCNF for a while, and we said it's great, but then we said it doesn't preserve dependencies. We talked about what dependency preservation is. We went through an illustrative example of what that would look like. Then we introduced third normal form and some characteristics of third normal form, and we talked about minimal cover. And we said if you want to put things in third normal form, you need to put it in minimal cover. Maybe get a chair from outside if you can't find one. So we talked about minimal cover, and we said there's 3 steps. You need to put FDs in standard form, then you need to minimize the left-hand side, and then you need to delete redundant FDs. We went through 2 examples. We did all of that. We did that. We said you can't switch the order in which you do these steps. And here's where we kind of ended. We said, here's the steps you need to take in order to put things in 3NF. Given the FD's F, you first compute F prime, which is going to be your minimal cover. Then you're going to decompose using F prime, violating 3NF. So you go through, and anything that's violating 3NF, you're going to decompose. After each decomposition, this is new and you didn't have it in BCNF. After each decomposition, you identify the set of dependencies N in F prime that are not being preserved. And if you get dependencies that are no longer preserved, you're going to add it back into your set of relations. So for each X determine A, which is not being preserved, you're going to add that back as a example. Let's go through a 3NF example together. So assume that this is my relation R of A, B, C, D, E. And I've got 2 functional dependencies of FD1, AB determines C, and C determines D. First of all, I'm going to put this in minimal cover. It already is in minimal cover, so that part is already good. I'm going to find my key. My only key is ABE. So if I have AB, that gives me C. When I have C, I can get D. I also have E in my relation. E is not here, so it needs to be part of my key. So ABE is my key here. So far, so good? So once I have my key, I am going through my decomposition rule. First of all, I'm going to look at AB determines C. And I'm going to determine whether it's violating 3NF or not. So there's 2 things I need to check. Is AB a superkey? AB is not a superkey, so therefore that one doesn't hold. The other thing would be to check if the right-hand side is part of a prime attribute. So is C a prime attribute? Someone remind me what a prime attribute is. It needs to be part of at least one candidate key, right? Is C a prime attribute? It's not, because it's not part of any keys. Therefore, this is violating 3NF, and I'm going to split on AB determines C. I'm going to get R1, which is ABC. I'm going to get R2, which is ABDE. Am I preserving all my dependencies? Am I preserving C determines D? C determines D is no longer being preserved, meaning I don't have a relation that has both C and D. Therefore, I'm going to introduce a new relation, and I'm going to have R3 of C and D, which is going to preserve that dependency. Right? Then I'm going to keep going. This is in 3NF. This is in 3NF. This is not in CNF. If you look at AB determines D, based on this functional dependency of AB determines D, AB gives you C, C gives you D. Therefore, you've got this implicit functional dependency where AB determines D, right? If you look at that, it's violating 3NF. AB is not key. D is not a prime attribute. Therefore, I need to further decompose to R4 and R5. And this will be my final answer. Now, most of this looks like the BCNF stuff that we were doing, right? There's two main differences. The way you check whether something is violating 3NF has one additional component that you need to check, that whether the right-hand side is a prime attribute or not. And the other thing is that if, based on your decomposition, you're no longer preserving something, you need to add that back in. And these are the main two differences. And the other big difference that we haven't done here, which was already in minimal cover, is that when you look at that first set of functional dependencies, if they're not in minimal cover, you need to put it in minimal cover before you start. Any questions? Okay, so I'll leave this example for you guys to go through at home. And we look at BCNF and 3NF. I thought I had one other question. Actually, let's do this question first. So this question should be sitting on Ripple. If we go to view, it's the last question. Okay, so I'll give you some time to go through that and then we'll cover it together. It's the last question on assessment 3 on Ripple. Okay, just another 30 seconds or so for you to think about this and respond. Bit more than 30 seconds. Yeah. You can't get into the Ripple now. How come? Yeah, what's going on? Okay, it was a little slow, but I got in. Yeah? Anyone still having issues? Fixed? Okay, good. All right. So most people going for C, some people going for other things. Let's take a look. So how would you approach this, right? So you would look at that relation, you would look at your functional dependencies, and you will do your violation test to see whether it's violating it or not. So what you would do is you would find, you would run some closures to find closures of a set of attributes, you find your keys, and then you look at whether D determines C. D is not a key, therefore this is not in BCNF. But C is a prime attribute because it's part of a key. Therefore, this is not in BCNF, but it is in 3NF. Right? And if you maybe go back here now, we see that looking at Venn diagrams, anything which is in BCNF is also in 3NF. So if you find something and you know it's in BCNF, it's also in 3NF. But you have some things which are in 3NF and not in BCNF. Right? So essentially, if you knew that, then which one would not be possible? B would not be possible, right? You won't get things which are in 3NF but not in BCNF. All right. I'll quickly talk about denormalization, but it's not really a key emphasis of this course. But all we've talked about so far is how do you avoid anomalies? How do you make sure that you decompose things so that you don't get any anomalies? In data science, and especially when you want to run analysis on big, large data sets, you might actually sometimes put tables together and introduce denormalization yourself. Now, this is often when you want to do a lot of analysis and you're not expecting the data to change much. If you expect the data to just be there for your analysis and not really getting a lot of new inserts, updates, or deletes, you might put everything together and denormalize it, which makes it easier to do analysis on, and you know that this is not going to be a trouble because you're not expecting this data to change. So the idea about denormalization is that you want to have performance improvements on top of your analysis, and you purposefully denormalize things and introduce anomalies into your data so that it would be easier for you to run analysis on it. And that is as much as we're going to talk about denormalization. All right, learning outcomes for this module. So we've talked about examples of modification, insertion, and deletion anomalies, explained the term functional dependency. Given a set of functional dependencies, you can infer F using the Armstrong's axioms. Given a set of functional dependencies that hold over a table, determine the key. I'm going to turn this down a little. My microphone. So determine keys and superkeys and compute closures using the closure algorithm that we talked about. Correctly decompose into one or more relations on decomposition. Justify why lossless joint decompositions are preferred. Explain the benefits of normalization. And then on the normalization side, be able to put things in 1NF, 3NF, and BCNF. Explain what dependency preservation is. And describe the process of denormalization. Any questions or thoughts, comments before we move on to SQL? This was just what was left of the previous module that we had to go through before starting SQL. Question?
Sorry about the ECNF and 3NF. So as you said, one is reducing redundancy, what is improving dependency. Where we choose, or how we choose which one is the better way to go?
Yeah, so that's a good question, and a lot of time comes down to the sort of queries you want to run on your database. I would say if you're doing a lot of insertions, then you want to have 3NF, because as you're introducing things, there's a chance that you might be getting things which are violating your functional dependencies, which are not being preserved. But if you already have a well-established database and you're not expecting as much insertions in, probably you want to reduce the anomalies and go with BCNF so you don't have as much redundancy. But this might just be a preference, or the way I'm thinking. It's both are used widely and standardly in industry for a variety of reasons. Good question, though. Any other questions? Okay, let's move on. Okay, SQL. This is going to be a rather long module. So we talked about those. We'll come back to these at the end of the module. SQL. Standardized language supported by all major commercial databases. It's an interactive use of graphical user interface or embedded in programs. and it's declarative, and it's based on relational algebra. Now, we're not going to talk about relational algebra in this course much. We're going to touch on it towards the end of the semester. But essentially, it is the foundation on which SQL is being developed on, relational algebra. And we're going to use it in order to do optimization later on top of our databases. It's declarative. So if you've done some Python, C, or Java programming, you know that your program is going to be run procedurally, right? You've got loops that's going to go through the loop, and you need to determine exactly what it is you want the program to do line by line. We're not going to do that in SQL. Essentially, it's going to be declarative, and you're essentially just going to be telling the system what it is you want to be returned, which is going to be very different in practice in how we write C or Python or Java programs. We're going to be using MySQL, which is an open source relational database management system. And we are going to use either MySQL Workbench. So if you want to run something on your own machines, you can download MySQL Workbench. It's open source, it's free, and it's a graphical interface that allows you to run things locally on your own machines. And we're also going to have zones for you that you can use the zones, and they'll be running PHPMyAdmin. PHPMyAdmin is also a free software tool intended to handle and administer MySQL over the web. So once you set up your zones, this is the PHPMyAdmin page that you would get. There was a note that was telling you how you can take the schema that I had in under Blackboard, and you can add it to PHPMyAdmin, and how you can run queries on it. So this Infs7901 is the example set of relations that I have. There's essentially two examples here. One example is on movie stars and movie stars, and I'm borrowing that from my colleague Rachel Pottinger from UBC during my UBC days. And there's another example here which is on students, colleges, and how they apply to colleges. This is a very North American sort of example where the colleges are Stanford and MIT and Cornell. And I'm borrowing that from Jennifer Withen from Stanford. She's one of the pioneers of relational databases. And essentially, we've got schemas of these two sitting here, and we're going to run some queries on top of those. The sort of SQL statements that we are going to be running are going to be either data definition language based, so DDL, or they're going to be DML, data manipulation language. So this is going to be a pretty long module. We're going to start by talking about how you create, alter, or drop table statements. Then we're going to talk about basic SQL queries. Then we'll talk about set operations and how you can run set operation-based queries in SQL. Then we'll talk about aggregation, group by, and having clauses. Then we'll talk about nested queries, which are fascinating and give you a lot of power. Then we'll talk about views, null values, and joins, insert, update, and delete and update statements. And we'll finalize with some discussion around constraints and triggers. Okay, so let's start by data definition language. DDL is one of the two main parts of SQL, and it's used to define the database structure. So before we actually start querying our data and instances, we need to create our tables, right? And DDL is going to help you create your tables before you can actually import data into it. So it is going to be used to create objects in the database in order to alter the structure of your database and the tables and relations you've got, or to drop or delete objects or relations from your database. These are the main three things we're going to do in DDL. So how do we create tables in SQL? Creating tables, you're going to have a create table statement, and through it, you're going to tell and specify the name of the table, the attributes that are inside it, and any constraints you might have as part of that table. Key, entity, and referential integrities. So referential integrity, someone remind me what that is? Foreign keys. And what are the foreign keys used for? Connecting to other tables, right? So any sort of keys, foreign keys, or any other constraints you have, you're going to define them as you create these tables. Okay, so let's do an example. This is what the syntax of creating a table would look like. You say create table, then that's the table name. Then you're going to have a bunch of attributes. For each one, you're going to have a column name and then the column type. And then at the end, you're going to have some constraints. There's some syntax words, keywords that you're going to have. So this is going to be an argument. This means it's optional, so you can drop it if you want or you don't. So these are the syntax I'm going to use in defining the syntax of how we do our queries. So anything that's capitalized is a keyword. Arguments, these are optional. Curly brackets mean you can get multiple of these happening, so you can get multiple table constraints. And this is or, giving you a choice between different things.
Does column type means the attribute of the domain?
Which one?
Column type means the domain?
Column type means the domain of what it is, yes. So an example would be helpful. So we had the movie entity from before. If you want to create that, you would say create table movie, that's the name of it. Then you're going to have a set of attributes, movie ID integer, titles is going to be character, let's say it's going to be size 20, year is going to be integer, and I'm going to have a primary key where that primary key is going to be movie ID. Right? That will define and create that movie table for you. Any questions? We all good? All right, what about relations? So relationships, let's take this stars in. That stars in is going to be between movie stars and movies. We've talked about that before. So the relation has movie ID and star ID as the primary key. There are two foreign keys. Stars in.star ID is referencing movie star.star ID. And stars in movie ID is referencing the movies. To create that, you're going to say create table, stars in, that's the name. You're going to have a set of attributes, star ID, movie ID, and role, integer, character. You're going to have a primary key where the primary key is going to be the combination of star ID and movie ID. There it is. You're going to have two foreign keys. This foreign key is star ID, which is going to reference movie star. And this one is movie ID, and it's going to reference movies. Now note that when I'm referencing movie star, I actually don't need to say what in movie star. Like I don't need to say it's star ID. Why? Why is it not necessary to define what attribute in that movie star ID I'm referencing for my foreign key? You can only reference primary key, right? There's no ambiguity there. The only thing I can reference is the primary key. Therefore, you don't need to say it. So in this example, we've got the create table, the name, the attributes, the primary key, and foreign keys. Any questions? Okay, enforcing referential integrities. So we talked about referential integrities, your foreign keys, but we haven't talked much about how you enforce them. So let's say you've got movie ID, and star ID is a foreign key that references movies. So stars in movie ID is referencing your movies.movie ID. Now, what should be done if a movie tuple is deleted? So let's say you have in this relation, let's say in this relation, you have a combination of a movie star that is in a movie, right? Let's say that movie is deleted. What do you think we should do? So, should we delete all roles that refer to it? So if we deleted a movie avatar, should we also delete all the references and stars in that said a movie star played in Avatar? Well, the movie no longer exists, right? So I can't say they played in that movie anymore. Essentially, what you want the system to do is a decision that you need to make here. And there's multiple ways you can go. So here's the multiple things you can do. You can either ask the system to automatically delete everything that any movie star that was playing in Avatar, automatically if the movie Avatar was deleted. This we're going to call cascade. So delete by cascade. If the actual tuple of the movie is deleted, delete anything that's referencing it. You can also say disallow the deletion. You can say, hold on, I'm not going to allow you to delete this because there are things that are referencing it. If you want to delete this, you need to go back, delete anything that's referencing this before I allow you to delete this. So that's another way to go. We'll come back to null and default in a second. But essentially what you can say is that you can say on delete, you want it to cascade. You want it to put it set by null. So that's another way to do it, right? Go back to that relation, and instead of saying that they played in the movie Avatar, just say they played in a movie and call it null. Now that won't be possible there because the movie ID is part of your key, and you can't have part of your key be null. But in other places that might be possible. So the sort of things you can do on delete or on update is to set it to null. Set it to a default value. Let's say I can introduce a default value and say, I'll call it the string deleted movie. And then I say, whenever something is deleted, put deleted movie instead. So I know that this is a default value, something was deleted there. Or I can cascade. Say, automatically delete anything that was referencing it. So if you want to go back to our relation here, when we define our relation, we can also determine as part of that relation, whenever we define a foreign key, so foreign key star ID references movie star, and then we say, if it's deleted, cascade, if it's updated, cascade. That tells the system, if something is deleted from this reference table, then automatically delete things from this table too. And you can do that per foreign key. So this is one for the first foreign key, and this is one for the second foreign key.
So this just deletes tuples from the stars in table, not from the movie star table.
Correct. So this deletes anything from the stars in table that was referencing that movie, or that movie star.
For the update, if something was updated in movie, it will be updated here as well?
Yeah. So let's say you update something in this table, in the movie star table. Let's say you change the ID of the movie star from one thing to another. It will automatically update here as well. So on delete or on update, you're telling it what to do. The default, if you don't add anything, is that it will disallow it. So if you don't add anything in, it will restrict it. And if you want to delete anything that's being referenced, it's going to say you can't do it.
You said that's the default behavior in the SQL standard?
Correct. Any questions?
So the code needs to be in two separate lines. What would happen if
So the question is, they're on different lines. What would happen if they're on the same line?
and also the
So the indentation is there mostly to help you understand where it is. For them to be on the same line, I'd invite you to try it out and come and report to us next week. I think it would be fine, but I'm not sure. So try it out. All right, I've got another clicker question for you. So this is now sitting on Ripple. If you go to the assessments, this will be on lecture 4. First question. feel free to discuss it with a neighbor before responding. Right, 30 more seconds. Ten more seconds. 9, 8. Okay, so majority of you going for A. A is the right answer, with some of you also going for B, C, and D. Now, the important part of this question is to determine, when you have a foreign key, which way the relation is. Right? Because sometimes it's confusing. Who is pointing to and who's referencing what? So in this example, you've got create table BMW. So that is your relation, which it has a foreign key to the student table. What this is saying is that a BMW would be owned by a student, so it's referencing the student that's owning it. Now, part 1 says if the row for student ID value in student is deleted, then the row with the BMW should automatically be deleted. And that is the case, right? Because it's referencing that, and there's a cascade there that says if the student is deleted, it's no longer able to reference that, that's deleted. But why isn't B right? So if a row with student ID, if the BMW is deleted, there will be tiers. The car's gone, right? That's deleted. But there's no reason why you should delete the student, because the student's not referencing the car. Right? And every year, we get a lot of people that get this wrong in their projects as well as in the exams. Make sure that when you are referencing things, you have a good understanding of who's referencing who, what is referencing what, and which one will be deleted if you take something out of your database. Any questions on this question? Are we all good?
So this cascade parameter, it's only associated with the foreign key? So if there's
Correct.
multiple foreign keys, you'll have multiple possible cascade?
Correct. So one per foreign key. Okay, so looking at that, your BMW here will be referencing the student table, and therefore A will be the right answer. All right, altering tables. So far we've talked about how you create a table. What if you want to alter the table at a later time? Right? By altering that table, I don't mean the actual data in it, but the actual schema of the table. Like you want to add a new column in, or you want to delete a column from it. So alter table would allow you to add or drop a column, change a column definition, or add or drop a constraint. These will allow you to change or alter your table. In terms of syntax, you will say alter table table name. If you want to add something, you can say add column with that type. If you want to drop, you can say drop column. You can say cascade. What would that cascade do? Drop, remove any information you have in that column, right? So anything that was stored there will be dropped. Alter column will allow you to alter a column. Add constraint or delete or drop constraint will allow you to add or drop constraints. We'll come back to those towards the end of the chapter. Similar with drop. Drop table would allow you to drop the entire table, right? Essentially that would delete the table. And if you want to drop the table, you can say drop table. Depending on what version of what database management system you're using, sometimes you need to add that if exists. If you don't have it and you say just drop table, sometimes it would say, give you an error and say the table doesn't exist. So drop table if exists, you give it the table name, and you can say restrict or cascade. If you say restrict, it will restrict people. It would restrict you from dropping this if you've got other tables that are referencing this. And if you say cascade, it will cascade and delete anything which is related to this. Right? So restrict and cascade always mean either delete everything that's related with it. Restrict means just don't allow it. And that is create, alter, and dropping table statements. Questions, thoughts, comments?
For the drop thing, when you drop a column, you say if you say cascade, then you drop the entire column. But what if you do not say cascade? What will be left? Because when you drop a column, you will drop a column, right?
So if you say restrict, it wouldn't allow you to drop it if there's data in it. So you might want to restrict it if there's current data there, and you only want to drop it if there's nothing currently there.
What if I do not say restrict or cascade?
I believe the default is restrict, on MySQL at least, but there might be differences in other versions or other database management systems.
Is it possible for another table to prevent this table from being used other than the restriction that has data?
That's a good question. So the question is it possible for another table to restrict this table from deleting? No. So the other table can say, I'm not going to allow a tuple to be deleted from my table if it's referencing someone else. But things that relate to this table will be done in this table, in the definition of this table. Or at least this is what I think. I might have to check and get back to you.
So otherwise you'd have a contradiction.
Right. Otherwise there'll be... Yeah, so that does make sense to me. All right. So that was DDL, Data Definition Language. We're going to talk about DML, where we're going to manipulate data. Data manipulation language is the other main part of SQL, and this is going to be by far what we're going to spend our time on. Data manipulation language statements are used for manipulating and managing your data. You can do select to retrieve data from your database. And again, this is where we're going to spend most of our time. You can also do insert. That would allow you to insert data to your tables. Now, note there's a difference between insert and create, right? Insert is inserting data into your currently existing tables, whereas create was actually creating the table schema. Same with update and delete. So update is updating existing data. Alter was altering the table. Drop was dropping the table, whereas delete is deleting rows. So everything here is at within a table, sort of, and with data. Whereas what we had before in DDL was about actually changing the tables themselves, not the data inside them. Okay, so in SQL statements, users specify what result they want. And essentially, it will be returned in terms of a relation to them. Now, if you don't know relational algebra, this is not going to be a trouble for you. But note that the SQL select statement has no relationship to the select operation of relational algebra. So if you're not familiar with relational algebra, you can just ignore that. If you are familiar with relational algebra, the select that we have in relational algebra is different to the select that we have here. And we'll come back to that towards the end of the semester. Okay, so what do you do in a basic SQL query? You'll have selection, you'll have where clause, where that where clause is going to be a horizontal scanner. The where is going to determine which rows, which tuples are going to be returned. Right? So where clause is going to be your horizontal scanner. This select clause is going to be your vertical scanner, saying which attributes it is you want to return. Join is going to allow you to join tables from different tables. You join them together so you can bring in attributes from multiple different tables. And sorting will allow you to sort the clauses in any particular way that you want. This is the syntax of your basic select query that you'll be running most of the time. It's going to have select from where. Select some attributes, which is what you're going to be returning. From is the set of tables that it's going to be referencing. And where is the conditions that it is going to say, these are the conditions that you need to satisfy in order to be in this result. Now, to begin with, if you want to find a systematic way to think about writing queries, I would encourage you to write select from where. So write select from where. Start by thinking about the from. Look at the query and see whether you can determine which tables need to be included for this query. Once you've got the tables, which goes into from, think about the where. Think about the condition of what it is you want to be satisfied, what conditions you want to be satisfied. Once you've got the from and the where, go back to the select and think about what it is you want to return. There's this distinct that you can add here, and that distinct is going to say that I want rows that are being returned to be distinct. So if you add that optional word distinct there, it is going to enforce that all of the rows that are being returned are unique. If you say select star, so you say select a set of attribute names, select star is a wildcard which is just going to return everything. Alright, let's actually do some examples. So this is the movie example. I have three relations. I've got movies, I've got stars in, and I've got movie star. Let's say I want to find the titles of my movies. So the titles are sitting in the movie table. So this is the table I need to reference. So I'm going to say from movie. What is it that I want? I want their title. So select title from movie. So I'm going to copy that over to my zone. In my zone, I've added this as based on the email that was sent out. So if you essentially go on new, you can create a, if internet's working, okay, so you can create a new database. I called it Infs7901. Once you create it, you can import the file that I added to Blackboard. And once you create it, you'll get these relations on the side, and you can run SQL queries. So if I run select title from movie and run that, this is the title of the movies that I have in my relational database. Right? So it is returning all the titles. And if you haven't done any SQL querying before, ta-da, it's almost like magic. You query your database and you get a table back. Any questions? Now, from this, select title from movie, you should be expecting a relation that only has one attribute, right? That's what I'm asking for. I'm only asking for the attribute. I'm only asking for the title. Now, if instead I run select star, what do you expect? So you movie ID, you've got title, and you get year. So title, that's what you would get. Any questions? Okay, then I've got another clicker question for you. This would be question 2 on Ripple. Okay, and for all these questions, feel free to talk with your neighbors. Okay, 10 more seconds. Okay, most of you think B. B is the right answer. Quite a few of you going for none of the above. Anyone want to speak on behalf of those that are going for none of the above? Yeah. Cool. So which of the following would be in the result, not necessarily the entire thing? Any questions? Should be relatively simple. All right. So let's do find all the years. Guys, quiet down, please. Let's do find all the years where a movie was produced. Right? And here, if you run select year. So let's go to SQL. We run that. So this is giving you all the years where a movie was produced, right? But note that I'm getting two 1927s and two 1928s and so on and so forth. Why? Why am I getting two 1927s? There's multiple tables that were produced in 1927, right? I'm asking for it and that's what it's returning. So if you want them to be distinct, if you just want the years, not necessarily to have multiples of them, you will add this distinct here. And if you do that distinct, now you're just going to get one row representing each year where a movie was produced. Right? So if you were thinking before, why do I need to add distinct? Because already all my tuples are distinct, because every relation has a superkey, right? Well, that's not the case when you run a query, because when you run a query, you can only ask for one attribute to be returned, and there's no reason for that attribute to be unique. Therefore, if you add this distinct, now you're going to get things that are being returned as being unique, each tuple being unique. All right, next question. So select distinct, team runs 4 from score. Okay, 15 more seconds. All right, so most people going for 5 appears twice. A few people going for 1 appears once. So if you do distinct team and runs 4, so you're looking for team and runs 4, you're going to get 5 appearing twice. You get it once here and you get it once here. 1 you get more than once. All right, quiet down, please. That's a good question. So the question is, can I move distinct from here to here after teams before runs 4? And what do you think?
I mean twice. You have it twice in one statement.
Yeah, no. Because that current distinct doesn't mean that team needs to be distinct. It means the entire row or the tuple needs to be distinct. So that distinct is not as an attribute level, but it is at a tuple level. Right? Does that make sense? So if I have 2 tuples, which one has 1, 1 and the other has 1, 2, these are different. If you use distinct, you get 2 different rows. If only they're equal among all the attributes, then distinct will remove it. You can't. So the distinct comes before any of your actual attributes. So you can't. So let's go back to here. Like if you want to move distinct after here, it'll give you an error, I think. So without distinct, we've done it. If you have it here, it's a syntax error, right? If you look at the syntax of how you do an SQL, a basic SQL, it's select optionally add in distinct or not before the attribute list. Right? So it needs to come before your attribute list. Yeah. No, so distinct is looking at the entire row. Right? So it's not looking at any specific attribute. So if, let's do, so when you run distinct year, it's going, let me see if I have another example. So let's also bring in title. That is 1927 is no longer, it's no longer a repetition, right? Now I'm going to get two different 1927s because the entire row is not the same. It is going to look at the entire row, not a particular attribute for distinct. Any questions? Let's take a short break, 5 minutes. We'll resume at 5 past. I'm not sure. Sorry, not sure. Maybe. All right, let's get started. Okay, so just by quickly going through the projects, there are some really exciting ones up there. So good job, everyone. Really looking forward to seeing some of these in action later. And can I also ask you to make sure that you do your weekly progress reports before you attend the tutorial, so that there's a discussion that you can have with Nick and Anna about where you are and what you need help with, right? And as tempting as it is, please don't just copy-paste what someone else has, which was happening in some of you, closer to the bottom of the file. Right? So think about it. Make sure that it's articulating well what you've done so far. And if you've got questions for the tutors, come with the questions. Is there a hand up? Yeah.
Yeah, this is not about a project that what they propose now will be able to update it or change it later.
Good question. Guys, quiet down, please. So the question is, if you make a proposal now, as based on your proposal, can you update it? And the answer is, to some extent. Like, I wouldn't recommend changing the entire theme, but essentially the second step is to go back to the feedback that we give you based on the proposal and retweak and revise the ER diagram and the functionality.
So, for example, we can delete some attributes.
You can. So any change to the current theme is possible, but going with an entire theme I wouldn't recommend. Updating the one is pretty much expected based on what you get out of the feedback. Okay, so also, I believe Nick has also now updated the Ripple grades for the first round. You can take a look later and get back to him if you had any questions.
Sorry, where is the break? Nick?
So it should sit under Blackboard, I believe.
My break?
So under my grade, you should be able to see your grade, yeah. You do get an email when your resource goes through moderation, right? Whether it was approved or disapproved. Yeah. All right, let's move on. Okay, so you can also add. You can also add some arithmetics to your queries, right? So for example, you can say select year plus 2 from movie, and what it's going to return is the year which is being returned, and then it's going to add 2 to it. Right? Okay, the where clause. So far, all that we have seen has just had select and from. We haven't added any conditions yet. How can you add conditions to your clause? So select set of attributes from your table lists. Where is going to be your join conditions and your search conditions? So there's 2 things you can do. You can either use them to join tables, or you can use it in order to select things based on a condition that you have. So I want you to think about this yourself first. Find all of the male stars. Think about that query and what would it be?
Select name from movie star where gender is
Select male.
from movie star
Yeah?
where gender is
Select name from movie star when gender is male. If you run that, what do you expect to see? A bunch of male names, right? Okay, what else do you have here? So you've got name and you've got gender. What do you expect to see if I do that? Just a bunch of male. And if I add distinct? Just one tuple being returned. All right, next question.
Few more seconds. Why do you even close it?
My laptop died because of the power.
Right. Okay. So close to getting 100%. Maybe next time. All right, so the condition is where runs is bigger than 5, so run bigger than 5. This one will give you, this one will be returning the results, given that 6 is bigger than 5. Any questions? We all good? Okay, this I just wanted to give you an example of what dates would look like. So essentially, you can think of dates as large integers, right? So if you want to say whether date is smaller than, 1941, you can just write it as a large number like that. If it's stored as a string or as a number, both ways you could run it like that, and that will give you the correct answer. So find events that have occurred before 1943 from this events. If you run that, that's what you would get, dates that are smaller than 1943. Okay, selection and projection together forever. So I've got two examples for you to do on your own first, and then we'll look at it together. Not sure why we were being counted. Okay, so if you're lost and not sure where to start from, write select from where. Think about the from, think about the where, and then think about the select, what needs to go there. You might have to go back in the slides to find the schema. Okay, so both should be relatively straightforward. Names of the female stars will be select name from movie star where gender equals female. And titles of movies prior to 1939 would be select title from movie where year is smaller than 1939. And let's just run one of them as an example. And these will be the title of those that are before 1949. If you want to check if that is indeed the case, instead of title, if you do star, you would also see the year, and you can see that all of these are smaller than 1939. Okay, so you can also have matching, string matching, happening as part of your condition, as part of your where clause. So if you want to find movies that have sin in them, you can say ampersand sign on both sides, and that is going to find any movie that has sin in it. Right? And there's a bunch of other ways. So the ampersand will stand for 0 or more arbitrary characters. But if you just want one character before it, then you can do an underline. So if you do underline sin ampersand, it will look for things that would have one character before sin and then any after. Okay, so this is a little different between one version of database management systems to another, or from one version to another. Here for your reference on what else you can do on things like in, like, is, between, and dates. I'll leave it for you guys to kind of play around with that later. So far everything we've done has been on one table, right? What if you wanted to get information from multiple tables? This is where we're going to have joins. Joins are going to allow us to get information that will be coming from multiple tables. So join combine tuples from different relations, from the search. You're going to have a join condition. So far we're looking at search condition. This was a search condition. It could also be a join condition. If you have multiple tables that are inside your from, you can also use alias, which makes it easier to write things. So you can say from stars in, and you're going to say that's S. You give it an alias, so from now on, if you want to refer to stars in inside your query, you just say S. So just a quick reminder of how we do joins. If you have two tables, R1 and R2, right? And then if you say R1.B equals R2.B, meaning that they would have the same B value, this is what you expect to get. You will expect to get things where this B is the same to be joined together in your relation. So you want to find the IDs and names of all the movie stars who have been in a movie. Think about that. So the first thing you need to think about is which tables do you need in order to answer that question? What would go in your from? So the name of your movie stars will be in the movie star table, right? So you need the movie star table. Which other table do you need? Stars in, right? If you just look at the movie star, you wouldn't know whether they've actually been in a movie or not. So you need both of these tables to determine and find those that have been inside an actual movie. So we're going to look at stars in, and we're going to look at movie star. I'm going to use alias S to refer to stars in, and I'm going to use MS to refer to movie star. And you want the star ID of S.starID to be equal to MS.starID. That's just going to match them from the two different tables. And what you want is you want their star ID and you want their name. And if they've been in multiple movies, I just want one version of it, so I'm going to add distinct. And this is what you should expect. Any questions? Should you use star ID in movie star? What do you mean? Here? It's a good question. So let's run it so it'll be easier to talk about it. So this is what we're running, right? And this is what we're getting. Let me take out the So you've got one star ID which is coming from the stars in, and you have another one which is coming from movie star. Now you've put it so that they're always the same. Right? You have a condition which says where that is equal to that. Does it matter which one you use? They're always going to be the same value. What happens if you do this? Just say star ID. It's going to bark. Why? It doesn't know which one you're referring to, right? You have two stars ID. You have two star IDs. One from this table, one from the other table. Now, although they're exactly the same number and it doesn't really matter which one you use, if you don't determine it, it's going to say that it is, the field is ambiguous and I don't know which one to use.
If the word distinct necessary
Is what necessary? Is distinct necessary? What do you expect to get if you don't use distinct? I want the IDs and names of all movie stars who've been in a movie. If you don't add it, you're going to get 5 tuples, giving you the same person if they've been in 5 movies. Right? So, if, for example, Clark Gable had been in 5 movies, then you'll get 5 rows here with that ID and that name. And that's not what you want. You just want the list of the people.
The second line there, star ends S and movie star ends S, that's just purely for simplification for further.
So that here I can just say S dot star ID instead of star Z.
You could have said star E.
Correct.
Star ID.
It's just messy. It's just messy. So these are aliases that you use to simplify referencing these tables. Yeah. Any other comments, questions? Okay, let's do a bit more complicated queries. Find the IDs, names, and characters of all movie stars who have been in the movie with movie ID 1. Right? So again, if you're lost, always start from where? Think about the from. What do you need to have in the from part? So we are looking for the IDs and names and characters of all movie stars who've been in the movie with movie ID 1. So the movie ID I can get here, the role I can get from here, and I also need the name, right? So I'm going to have stars in, I'm going to have movie star, I'm going to have my join condition be where star ID and movie star ID are the same. And I'm also have my search condition where movie ID equals 1. And what am I returning? I'm returning the star ID, the name, and the role. Yep, and if we run it, so what is this giving you? This is giving you the star ID, name, and the role of the person that is played in movie ID 1. Any questions? This one I actually want you to think about. So try writing this yourself. You're finding the ID, name, and character of all movie stars who've been in the movie with title Gone with the Wind. Which tables do you need? All 3.
Movie star and star scene.
movie star and stars in? Do you not need movie? You need the title, right? Title equals, so you need movie too. You need all three. If you're a little lost, feel free to work with a partner. Now, SQL is one of those things that it's much easier to see the query rather than actually write it, right? When I show you the query, it's like, yeah, that makes sense. Yeah, I would have come up with that. But when you actually start writing it, it does take some time to master and practice on it. Now, note that there's no way to go directly from the relation movie to movie star. Right? To go from movie to movie star, if you want to make any bonds between those, you have to also include stars in. Because movie ID, this is the bond between movie and stars in, because you can join them through movie ID. And the bond through stars in and movie star is through star ID. Whereas there's nothing, movie ID here and star ID here, there's nothing that can bond movie and movie star together without that stars in. So anytime that you need those two, you would also need that stars in table in between to kind of connect them with one another. Okay, so you're going to need all three tables. You're going to have stars in S, movie star MS, and movie M. You're also going to have the join conditions, which is going to join them. So S.star ID equals MS.star ID, and S.movie ID is going to go equal M.movie ID. That's essentially just getting the connections between your tables, right? What is my condition? My condition is that I want the M.title to be gone with the wind. So I've started by thinking about my from, that was my where, and then I'm going to add my select.
I wrote, instead of like, I have equal sign and a word. What's the difference?
So like and equal sign, what's the difference? Like is a little bit more forgiving with strings, and it depends on the version as well. So it might work with a string when you've got a like and not unless it's exactly the same with an equal sign. But it would work with an equal sign if you have exactly the right value. Yeah?
So why do you put equal in front of the where? Can you say this where the movie title equals to 1?
So why do I have these? Why do I have those? So if I have multiple relations in my from, I need to connect them with one another. Otherwise, the things that I get on the same line are not going to be related to the same movie or the same person. Let me demonstrate. So first of all, let's run this. So this is going to give you the star ID, name, and the role of people that have been in the Gone with the Wind. Now let me take out this, and this, and this. What should I expect?
Every star, or the name role, and everyone.
Yes. Yes. So it's going to give you every combination because you're not matching it based on the things that it's going to relate to. That first thing when you say star ID equals the movie star, it's going to put it so that only movies that I've played in will be matched with that movie star. If you take them away, I don't have a marker here. I should bring one. But let's say you've got a table which has 2 tuples and another one which has 3 tuples. If you don't add any conditions of the equal signs between them, you're going to get the Cartesian product of 2 multiplied by 3, 6 all combinations happening in the join if you don't actually have the join conditions in. That's a good question though. Any other questions?
Do we need to add I'm before title?
Do you need?
Add I'm before title? I think title is the only one, so we don't need to.
M dot title? Do you need M dot title? That's a good question.
Maybe we can just use title.
Yeah, so having title would be fine because there's no ambiguity, right? Because there's only one title. So that would be fine. But if it's things which are in multiple tables, then you need it in.
Excuse me, could you explain again about the difference between like and equal sign?
Yeah, so equal sign, we'll expect it to be exactly as it is with all the spaces in it as well. Right? So the string to exactly match. The like will be a bit more forgiving on capital cases if you've got a capital there, so it's like it.
But when I tried the equal sign, it also does not distinguish capital or not capital.
It might be different. So this is MySQL. Even within MySQL versions, there are varieties. The SQL standard, and this is actually pretty interesting. So when SQL was coming out, there was a lot of vendors that wanted to be the first to the market, including IBM, including Microsoft, including many different vendors wanted to be the first one. So they didn't really wait for the SQL standard to be completed before they gave out actually their products. So if you look at the different products which are in the market right now, not all of them do the SQL standard correctly or obey everything which is in the SQL standard. But I'll take a look and see how the two will be different in the equal and the like.
I just searched it, and I might be wrong, but it said that like can do the
Ampersand signed as well?
yeah, where's an equal sign?
So I guess if you do this, this wouldn't work with the equal sign. Thanks for that. If you do equal, it's going to essentially, my guess is take the ampersand, not take it to be meaning ampersand. Okay, did that. Okay, I've got another question for you. Now this, I encourage you to work with someone. It's pretty hard. So one way to do this is by the process of elimination, right? Try to see if you can get each one or not. Okay. So most people going for A, though quite a few going also for other responses. So process of elimination. First of all, note what you're returning is R.A, R.B, S.B, and T.B, right? So that's important. What's in the select is going to be those four things. Now, once you've notified that, then for this not to appear, that means you shouldn't have 1, 1, 1, 0, or 0, 1, which you do. So you want the S.A to be equal to R.B and S.B not to be equal to T.B. And essentially, there'd be different combination of things that you need to check. This will appear twice, and those are the two combinations that you can use in order to get that.
It says R would be equal S, right?
Yeah.
So to put this condition,
Guys, quiet down, please. R.B equals S.A. Right, so R.B, S.A. These two need to be the same. Yeah. Right, second column of R, first column of S. So this needs to be equal to that for this to be it.
can I show you something? It's easier to explain my question.
Can we, maybe we can talk it after class, if it's, because other people can't see it there.
I mean, if we want to look at R.B,
Yeah.
S.A.
Yeah.
So the only item that matches like this equality is the first item in the column of R and the last item. Right?
So that could be R.B equals S.A, right? R.B, S.A. So this is one, that matches. This with this matches.
I mean R, A and B, 0, 0.
Yeah.
So RB is 0 and and SA is 0 as well.
Yeah. So this and this, and this and this.
And the last tuple, which is 1, 1.
Yeah.
So
So you could try building that table, like the entire table, and look through to see which one of these is true. And that seems to be what you're trying to do. So essentially you're trying to build a table. Or this is just by process of elimination, I'm trying to look for combinations that will match that. All right, renaming attributes. So SQL allows you to rename relations and attributes using the as clause. So I can say select title, role, and then I can rename it as role 1. Right? So the as clause allows you to rename it. Role as role 1 is just going to, when you get your relation, it's going to call it role 1. So for example, if you want to find the title of a movie and all the characters in them and rename role to role 1, this is what you do. Try select star does not remove duplicate columns. So I don't know why I have that there, but let's try it. So first, if you run it with that, note that we get role 1 here instead of role. And if we run it with star, I guess what I'm referring to is that here when you run it with star, you're going to get 2 movie IDs. And sometimes if you want to differentiate things, you might want to use that as in order to rename things.
Is this only display or is this probably
This is just for your display. So this will not actually alter the table to call it correct. No database impact. All right, sorting. So if you don't specify any order by, there is no guarantees in what order you're going to get your relation. And essentially we've talked about the fact that in relations, the order of the rows doesn't mean anything, right? So if you have 2 things and you change the order of the rows, it's the same relation. If you want to enforce a particular ordering, you're going to use order by. So far we had select from where. You can add order by after your where, and this is going to be order by, column name that you want order by, and you can then say ascending or descending. So ascending is for ascending order, which is the default if you don't mention anything. Descending will be for descending order. Now here you can say multiple columns, right? So this says you can add multiple things to your order by. What does that mean? So if I order by last name then first name, what would that do? So sort based on the first thing, resolve conflicts based on the next thing. Right? So if you sort by last name, first name, it's going to first sort by last name and then resolve conflicts based on the second thing that you have. Actually, why don't you write this first? So you want to write in alphabetic order the name of actors who were in movie 1939. Okay, if you're finding it hard, start with the from, find the relations which are going to be in, then think about the word clause, then think about your select, and then add in your order by. Okay, so I want the year to be 1939. Year is in my movie, so year is the 1939. Order by name. Name is in my movie star, so that's name. I want things from here, I want things from here, therefore I need all three tables. So I'm going to have all three tables and I'm going to join them based on the star ID and the movie IDs. And at the end I'm going to add order by name. So let's run that. And that is what we get. If we take out the order by name, there's no guarantees in which order you're going to get that, right? Any questions? All right, I've got a question for you. Yeah. As if there were other types of questions. Okay, so this is a little tricky. Okay, 20 more seconds. Yeah, so identify one such couple is essentially. You're right. It's kind of like, think about conditions that need to be satisfied. Alright, so C it is. Right, and most of you are correctly going for C. so what condition must be satisfied? It's not asking for any conditions, so the question could be better phrased. Thanks for that. Identify one such tuple from the list that essentially this happens, where it would precede the tuple 5, 5, 5. So you have some conditions here, and you want to know which one of these you'll see in your table that would precede 5, 5, 5, right? So 3, 6, 5, given that you are doing descending on your C, is going to be below 5, 5, 5, because 3 is smaller than 5. This one is going to have a similar value. So these two 5, 5s are the same. So actually you don't know whether it's going to be above or below, right? So it could be either above or below. This one definitely is going to be above. Now I've got some references here to .sql files. And essentially if you go on Blackboard, I've posted a zip file which has SQL code for running all the SQL clicker questions that I have, so you can run them yourself to kind of see what it would look like. Right, and you can do that to kind of check some of these questions yourself. Any questions on this question? Let's take another 5-minute break, and then we'll resume at 5 past.